Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 2 of lesson number 9, Force and Laws of Motion. So now as you know that we discussed on force and about the 3 laws of motion in the last class, and there were many additional points that we had even discussed on, right? Like because the last part, that is part 1 of lesson force and laws of motion, was actually the introductory part where I have introduced the whole lesson with you, right? So I just want each one of you to please go through whatever notes you have taken so far, because that is all very important. Okay? And you have to keep on going through that because that is what is going to help you further as well. Okay? So everyone please start revising whatever note you have taken in your book. I hope every one of you are going through it. We even discussed on the definition of force, motion, about the frictional force, then first law of motion, second law and third law of motion, Newton's law, right? We have discussed on that as well. I hope every one of you are revising it. See, you have to revise each and every definition that you have written, because now we are starting with the exact lesson that we have. Okay, that is like exactly the lesson. So we are going to start discussing about force and all, but you have to make sure that you know the previous part. Okay. So now the first thing that we are going to discuss in the lesson is about force. Now before like discussing on anything, if you remember, like you might have revised it now, we even discussed on the definition of push and a pull, right? So if you can see the diagram, the pictures which have been given, not the diagram. The first picture is the trolley, like the boy is moving the trolley, right? So the trolley moves along the direction we push it. Now, if you're going to push the trolley forward, the trolley will move forward. If you push it backward, it will move backward. If you push it aside, it will be aside, right? So it means wherever in whatever direction you're going to apply the force, it is going to be in the same direction, right? And then the second picture that we have is the drawer is been pulled. Now whenever you have to open the drawer or close it, you have to pull it towards you, right? So in that, like you apply the force in that direction itself, so that you're pulling it, right? And the third picture is about the hockey. So the hockey stick hits the ball forward. So we all, like you might have played hockey, right? And the hockey stick that we have, in whatever direction you're going to like hit the ball, it is going to move forward and is going to move from its rest position, right? So it means we can say that for moving any object from its rest position or from a stationary position, we need to apply force, right? So how can we define force now? It is a push or a pull on an object that produces acceleration in the body on which it acts. What is force? It is a push or a pull on an object that is going to produce acceleration in the body. Acceleration means you can see it's moving from one place to another. That is what acceleration is, right? So push or pull of an object that produces acceleration in the body on which it acts. And here we have the SI unit of the force. Like let's say if you are calculating force, the SI unit of the force is going to be Newton. Okay. After that, we have some more information given over here that a force can do three things on a body. What it can do three things on a body. It can either change the speed of the body, it can change the direction of the motion of the body, and it can even change the shape of the body. So these are the three things that a force can do on the body. Now I'm going to repeat it. You have to remember it. Now these are another things that we need to rectify, right? So you have to understand this. Whenever you apply like more force, and if it's on like any object, you're going to change the speed of that object, or let's say body. It can even change, like if I am changing the direction in which I'm applying the force. Let's take the example of the trolley itself. If I'm like taking the trolley forward, it will move in forward direction. If I take it backward, it will move in backward direction. So we can say that force can even change the direction of the motion of the body. And lastly, it can also change the shape of the body that has been represented in the beside picture that we have. Let's say an example of spring or a rubber ball, or a ball like spongy ball, you can say. When you press it, the shape changes, right? And that is the same in case of spring as well. As in when you apply force, like it's like push and pull, and in that case the shape of that object is going to change. So force can do three things on the body. It can change the speed of the body, it can change the direction of the body, and it can even change the shape of the body. Okay, so you should be like knowing it, how to define force. It's like push or a pull that produces acceleration in the body on which it acts. And the SI unit of force is Newton. It can do three things on a body. It can like change the speed, it can change the direction, and it can even change the shape of the body. These are the points that you need to know. So I want you all to write these points in your book. Please take proper notes of it so that you can refer it anytime you want. I hope every one of you are like taking notes on force and writing like what exactly it does on the body, what is the SI unit. See, SI unit can be asked as objective as well, that what is the SI unit of force, or like they can ask you for a like calculating force as well. And when you calculate force, the unit that you need to add is Newton. Okay, and like Newton is the full form that you write in short form. You can write it as capital N, just capital N, nothing else. Okay. I hope every one of you are writing it properly. Because after this, like, I hope now you know about force, the SI unit, and what it can do to our body. Now the next thing that we have is effect of force can be understood by the following points. What can we say? That the effect of force, it can be understood by the following points. So here we have the points. The force increases the speed of a moving object, or it may also move the stationary object. Let's say if I have a ball on the ground, okay, if I apply force to that, it can even increase the speed of that object, right? But also if the ball is like coming and like in front of you, someone has thrown it, so you can even catch it, right? You can even stop that, right? That is in the second statement. But like here you can consider the ball as the stationary object, right? So we can move that stationary object, and by applying more force to it, we can even increase the speed of that object. So like taking the example of the ball is the best example, I guess. Okay, after that, force can stop the moving object, or it can just decrease the speed of the moving object. Now if we can increase the speed, we can even decrease the speed. If you are able to increase the speed of a moving object, you will be able to decrease the speed as well. And if you are able to move the stationary object, you can even stop the moving object. Okay, so the effect of the force changes the direction of the object. Whatever effect of force that we have, we know that it can even change the direction, it can change the shape, and it can even change the size of the object, right? So these are the four effects of the force that I want you all to please take a note of. The first two are very important, and the last two is like we already discussed about them, about that, right? So everyone please write these points in your book. Like you can get this for 2 marks to write the effects. I hope every one of you are writing the effects. I hope every one of you are writing these points and you have like even understood the point, because I don't want any one of you to rectify these basic concepts on force. Okay, and force is something that you have studied even in your earlier classes as well, right? After this effects of force, we have two different types of forces to discuss. One is balanced force and the other one is unbalanced force. Okay, now if you remember, we have already discussed about balanced and unbalanced force in the last part, because as I told you that these are the basic things. So what is balanced force? And if you remember, we discussed it with the example of tug of war. When you play that game tug of war, if both of the team maintains a balanced force, like there will be like no team will win in that case, right? And as soon as there's an unbalanced force at like in that game, as one of the team is applying more force, the team wins, right? So that is one of the best example to understand about balance and unbalanced force. Okay, so let's see what they have given for balanced force. So a force where two forces of equal size act on a body in opposite direction. Now two forces are there, but they are equal in size and they are like acting in opposite direction. Then we call those force as balanced force. Okay, and in a balanced force, a body is going to continue to be in its position. It is not going to move. It is going to like, why is it not moving? Because the force applied by from both the end is equal in size. Okay, so force, it may be continuously moving with the same speed in the same direction, or it may be still in its position. Okay, for example, they have given for balance forces. Suppose you are pushing a wall and as expected, the wall does not move and neither do you. Why is it so? Why the wall is not moving and why you are also not moving in that case? Because there is an equal force which has been applied by the wall as well as by you, right? So it means that you and the wall, they are exerting a balanced force on each other. Okay, so that is the reason that like you're unable to move it, but as soon as there's an unbalanced force acting there, at that time you will see that you will be able to move the wall. If there's an unbalanced force, if the force applied by you is more as compared to the wall. Okay, So I just want you to write the heading as like forces can be of two types, balanced and unbalanced, and write about balanced force in your own words. I hope every one of you have started taking the note on it. See, you can even write the example in your own words for your proper understanding. Okay, and the reason of you writing the note is so that you're aware of whatever we are studying. Okay, and you need to revise it before we start the next part as well. So that is the reason we are making notes as well. After this balanced force, we will be even discussing on unbalanced force, and that is going to be the opposite of it. Okay, so make sure you understand about balanced force properly so that we can continue with unbalanced force as well. After this, like balanced force, we have unbalanced force to discuss. So see, a force where two forces acting in opposite direction on a body are not equal in magnitude and size. Over here, what's happening? They are not equal in magnitude and size. Then we call it as unbalanced force. The meaning of unbalanced force is so clear that the force acting in opposite direction, like two forces acting in opposite direction, if they are not equal in magnitude and size, then we call them as unbalanced force. Okay, so in unbalanced force, a body can change its position. That is, we can observe a moving object changing its direction. Either they will increase the speed or they will decrease the speed of a body which is at rest, and that is going to start to move, and vice versa will happen. Like it can either increase or decrease the speed, right? So it will be according to that. And practically anything that move is a result of exertion of unbalanced force on it. Now, if you are able to move any object beside you, it's because the force applied by you is more as compared to the force that the object has applied. So, because there is an unbalanced force acting between the object and the you are able to move the object. So, any object, be it any object. Now, if I say let's say something which is very difficult for you to like move, let's say a very heavy dining table which you are not able to move, or the bed of your bedroom, they are all very heavy, right? So in that case, because the force is balanced over there, you're not able to move it, but as soon as it becomes unbalanced, you will be able to move it. The force applied, like you know that if the bed is very heavy, you need 8 to 10 people, or like at least 5 to 6 people to lift that, so that the force applied becomes more as compared to the force of the bed, and making it unbalanced, first making it unbalanced, and then after that only we will be able to, you can say, move it, right? So anything that moves is because of the exertion of unbalanced force on it. Okay, so if you kick a football and the football moves from one place to another, it means that unbalanced forces are acting upon it. Okay, what I said, if you kick a football and if the football moves from one place to another, it means that unbalanced forces are acting upon it. Okay, so I want you all to like write a brief note on unbalanced force in your book, and if you want, like you can draw the diagram, like the figure that they have used to show that. Okay, and I want you all to like take the note properly, so that whatever we studied you are aware about it, because you need to compare the balanced and unbalanced force both, and you can even get to write a differentiation on it. So make sure you're taking all the points properly. You can even draw the figure like representing the unbalanced force, that is like with the example of a heavy box which have been lifted by two people, right? And they have shown the direction of the box as well. So you can explain it in your own words, or if you have any other example, With respect to unbalanced force, you can write that as well. So like after writing about unbalanced force, you can even like try to differentiate that. What all points you can include for differentiating balanced and unbalanced force, you can write that. Okay? Once you're done with this, we will be discussing on the first law of motion. Now this lesson is like not that huge. We will be completing it soon. So make sure you keep on revising it because you won't have much time then to revise further, right? So make sure you keep on revising whatever we are studying. Now after this unbalanced force, we are going to start with the first law of motion. So let's see what does it states. And first law of motion is somewhat related to inertia. So we also call the first law of motion as law of inertia. Okay. So see, by observing the motion of objects on an inclined plane. Okay, inclined plane means a bit slant. So the motion of an object on an inclined plane, Galileo deducted that objects move with a constant speed when no force acts on them. Now suppose if the object doesn't have any force on it, at that time Galileo stated, like he deducted this part, that objects are going to move with a constant speed. Inclined means it's going to be slippery, right? So if it is inclined, the object is going to move because it's slant and slippery as well. So it's going to move with a constant speed when no force acts on them. And he observed that when a marble rolls down an inclined plane, its velocity increases. Now just consider the marble roll, and when that marble rolls down the inclined plane, its velocity will increase. Okay, and in next chapter you will learn that marble falls under the unbalanced force of gravity. Now when we start with like lesson 10, you will know it more clearly about, like we'll be studying one example with respect to marble, which is like they fall under the unbalanced force of gravity as it rolls down and attains a definite velocity by the time it reaches the bottom. So till the time it reaches the bottom, it's going to have a definite velocity. Okay, and its velocity will decrease when it climbs up as shown in figure 9.b. Now this is an inclined plane. Okay, so here you know that the object will not stop, and as we have taken marble, the marble will not stop. It will move down and move up like continuously, right? So its velocity will decrease when it climbs up as shown. Okay, so in figure 9.5, like see, it shows a marble resting on an idle frictionless plane inclined on both sides. Where is it like inclined? It will be inclined on both the sides, and it will be acting as an idle frictionless plane. Okay, so Galileo argued that when the marble is released from left, it will roll down the slope and go up on the opposite side to the same height from which it was released. Because Galileo had already deducted that objects are going to move with constant speed when no force acts on them. This was deducted by him. So he started arguing on this fact that when marble is released from left, it will roll down the slope and go up on the opposite side of the same height from which it was released. So if the inclinations of the planes on both sides are equal, inclination means the one that is like the plane is inclined. So if that inclination of the plane are equal, then the marble will climb the same distance that is covered while rolling down. Okay, so these are a few essential points that the argument of the Galileo on some of the facts have been given, and how exactly the velocity will act when the marble move up or when the marble like slopes down. That information has also been given. So before that, like we have some more points to discuss on, but before that I want you all to please write some of the important points that you find. I hope you all are writing the points from the screen. So once you're done writing these points, we will be like, there's one more part that we have to discuss on the first law. This part we'll discuss on, actually it's a very huge part, so we'll discuss, like, let's see if we can discuss on all. I'll just discuss till here, and then like Newton further, whatever like studied he did, we'll discuss that later. Okay, so see, here we have some points on angle. If the angle of inclination of the right side plane were gradually decreased, so if I decrease the angle of inclination, okay, of the right side, then marble will travel further distance till it reaches the original height. Where will the marble travel? It will travel more distance till it will reach the original height. So that is the reason that like we can make it like go to the right side plane, like we can have the inclination to the right side. So if the right side plane were ultimately made horizontal, that is, the slope is reduced to 0. So in that case the slope will be reduced to 0. Marble will continue to travel forever trying to reach the same height it was released from. So if the slope will become 0, it will become very difficult to, like, difficult for the marble to reach the same height again because of the unbalanced force. Okay, so the unbalanced force on the marble in that case will be 0. Okay, what will be the unbalanced force? The unbalanced force of the marble in that case will be 0, and it does suggest that an unbalanced force is required to change the motion of the marble. What is required? An unbalanced force will be required to change the motion of the marble, but no net force is needed to sustain the uniform motion of the marble. Like if we have to sustain that uniformity of the marble, we don't have to apply any force. But if we have to change the motion of the marble, in that case some external force has been required, unbalanced force has been required. Okay, so in practical situations, it is difficult to achieve a zero unbalanced force. Like if I talk practically it's very difficult to achieve a zero unbalanced force, and that is because of the presence of frictional force which is acting on the direction, like which is acting opposite to the direction of the motion. Why is it so? Why is it difficult to achieve a zero unbalanced force? Because of the frictional force, and wherever there will be frictional force, it acts opposite to the direction of motion. So that is the reason that applying a zero unbalanced force is difficult. Okay, so thus in practice the marble stops after traveling some distance, and the effect of the frictional force may be minimized by using a smooth marble and a smooth plane and providing a lubricant on the top of the plane. How can we reduce the effect of frictional force? By minimizing, like we can minimize the frictional force, because if there's frictional force, then zero unbalanced force is not possible, right? So we have to minimize the frictional force, and we can do that by using a smooth marble and a smooth plane, as well as like that smooth plane is going to provide a lubricant on the top of the plane. Okay. I hope you all are writing it. You can even draw figure 9.5 showing the downward motion, upward motion of a marble on an inclined plane and the double inclined plane as well. After this, like, we have more to discuss on this, which I'm going to start with in the next class. Okay, so I'll be starting completing the first law of motion along with this activity 9.1 in the next class. Okay, after that we will be discussing on one more activity, that is activity 9.2 in detail. Then we have 9.3 activity, and after this, after discussing the first law of motion, like in short, we have inertia and mass to understand properly. So we'll be discussing on inertia and mass, and then after the first law, we have second law of motion to discuss in detail. We'll be doing that as well, and then we have some of the mathematical formulations of the second law of motion, which we will be going through. And after discussing that in detail, like you can see, we have many examples which have been given. So we have example 9.1, where we will be calculating how to find the final velocity of the object. After that, we have 9.2, where we will be finding out the greater force which has been accelerating. Okay, then after that we'll discuss 9.3 activity, where we will calculate the force exerted by the brake on the motor car. Okay, after that 9.4, where we will be discussing the acceleration, like if both the masses were tied together, what will be the acceleration in that case. We'll discuss that as well. Then we have example 9.5, where we will be discussing on like how much force does the table exert on the ball. Like looking at the figure, we'll discuss on that. And after that, we have third law of motion at the end to discuss, which states that, like, you can say two forces, like two opposing forces are action and reaction forces, right? So like it is always going to be equal. So after that we will discuss on, like, it's a very huge part, then we'll be discussing on activity 9.4 as well. Okay, then after this activity 9.4, we'll discuss on conservation of momentum. Okay, then we'll discuss on this activity 9.5 in detail. And after that 9.6, then example 9.6, where we will be finding out the velocity of the pistol. And after that we will discuss on example 9.7, 9.8. So like there are more examples in the lesson, we will be discussing them all, and then we have the summary discussion that we will be doing. Okay, so after this summary, we have few exercise questions as well to discuss, which I'm going to show you one by one. But before that, I want you all to please go through the summary, like as we haven't studied much, but we will be going through the summary, and these are the exercise questions which I want you all to go through. I hope you all are going through the question. So this is the last question that we will discuss for the lesson, force and laws of motion. And I hope whatever we discussed till now in the lesson, you are very much clear with it. What is force, what are the effects of force, and then we even discussed in short about the first law of motion. Okay, now rest of the part that I have shown you, I will be continuing with that in the next class, but make sure you keep on revising everything that we are discussing. Okay, so I'll be starting with the rest of the part in the next class. Thank you everyone.